turning a carport into a service bay with a Katool KT-4H110 4-post lift. In 2009, we downsized from a house on 3 acres with a 2,400 square foot shop to a suburban home with a 3-car garage. The 3-car garage became a shop and video studio with parking space for 1 vehicle. The 2 carports have provided parking space for our vehicles. I kept all the tools and equipment from the big shop, with the exception of the 9,000-pound capacity forward 2-post lift. For the last 16 years, all my automotive work and hundreds of videos have been done within the 480 square foot garage and on the driveway aprons. Needless to say, every time I knelt down and rolled beneath the vehicle on a creeper, I thought about that lift. We like our property, especially the lower overhead. Last summer, I got a brainstorm to convert one of the parking carports into a service bay with a 4-post lift. The carport slabs are approximately 240 square feet each, built on 6 to 8 inch thick, high-strength, crack-free concrete. A lift for our suspension-lifted Ram truck with 37-inch tires requires a high ceiling. I raised one carport's height by 3 feet to accommodate our 2000 Holiday Rambler RV trailer. That could be done to install a lift. After researching lifts, I chose the Katool KT-4H110 4-post service and parking lift, plus 2 7,000-pound capacity RJ70 rolling jacks. The lift's dimensions were right for the carport. In addition to enhancing service work on our vehicles, this lift is optimal for demonstrating automotive work for the channel's videos. Creating a service bay with a lift required raising the carport's height by 5 feet and adding concrete extensions to the existing concrete slab. These extensions provide outer support for the lift's columns. The KT-4H110 lift fits neatly within the carport's footprint. Columns align with the carport's legs. The first step was to disassemble the carport's sheet metal trusses and legs. Lift column bases straddled the carport's rails. For supporting the column bases, I dug 12-inch deep space for concrete pads. The clay-like soil was relatively easy to dig and square up. I dug under the rails to clear away dirt from the original slab and washed away debris. I compacted the soil before laying 4 inches of 3/4 inch crushed roadbed rock in each hole. After compacting the rock, rebar was tied onto chairs and mated up with a 6 to 8 inch thick original concrete slab. There is a protocol for pouring a floor or slab for a vehicle lift. The column area should be a continuous or monolithic part of the pour. Edges of the column's foot should be at least 6 inches from any concrete joints. Here, we have an existing slab with embedded carport rails. The result is a one-off approach. For a new slab, follow the concrete protocols described in the lift installation manual. If the pour is unusual or a modification to an existing floor, consult with a specialist or engineer. To compensate for our configuration, the new concrete is 8 inches deep, steel reinforced, and butted to the original slab beneath the rails. Weight bearing for a 4-post lift is downward, with the vehicle on the runways. The column bases straddle each of the rails. 19-millimeter concrete anchors were supplied with the lift. Heavy-duty steel, hot-dip galvanized shims distribute the load evenly between the concrete extensions and the main slab. Had this been a new pour for the carport, the concrete would be a smooth and level monolithic pour. With carport rails embedded into the slab, a 6 to 8 inch thick pour would have additional depth beneath the rails. Support for the rails would call for 6 or more inches of reinforced concrete below the rail at each extension. A 2-post lift, by design, would require a much larger steel-reinforced concrete area around each column base. Consult with a concrete expert or engineer to confirm the safest pour method for your lift. Always consult a concrete expert or engineer when doing a lift project. Make sure the concrete and reinforcement meet or exceed the requirements described in the lift's installation manual. I always go beyond the load requirements. Minimum concrete depth requirements for Katool lifts depend on the specific lift. The KT-4H110 calls for 5.9 inches. I went with a steel rebar reinforced 8-inch thick concrete. Recommended concrete is 3,000 psi minimum. I chose 4,000 psi crack-resistant fiber-reinforced cement. A thorough spin in a cement mixer assured uniform aggregate mixing. The steel rebar and a burlap water soaking for the first 7 days after the pour increased the concrete strength. Milder 50 to 75 degree Fahrenheit early fall weather was ideal for a high-strength cure. 8 weeks of curing passed before I began assembling the lift. Total cure time before a vehicle load went on the lift was 90 days. This was optimal for an 8-inch deep, steel rebar reinforced pour. Once the concrete extensions gained good initial strength, we modified and reassembled the carport. I purchased 60 feet of 2.5-inch square, 120 thousandths wall thickness, American-made rectangular steel tubing, and lengthened a dozen legs by 60 inches each. When welding the uncoated mild steel tubing to the original carport tube sections, I welded double reinforcement plates at each joint with pairs of 134 thousandths of an inch thick, 2-inch wide flat steel plate at each tube junction. 0.035-inch MIG wire with fresh 75-25 argon CO2 gas worked well for the indoor welding. My breathe-cool remote air supply keeps the helmet clear and face protected when welding older galvanized steel. Once welded and installed, the lengthened legs were coated thoroughly with Rust-Oleum cold galvanizing paint. The Breathe Cool is essential for priming and painting as well. The original carport structure and its rail anchors were rated for 125 mile-per-hour winds. To compensate for the height increase, I added 30-inch chrome-plated screw anchors, stainless wire rope, and quality hardware for added support against our high winds. Thimbles and cable hardware are either stainless steel or zinc-plated for long life. This has worked well for a decade at the opposite carport. Reassembling the carport required renting a 19-foot scissor lift with a cage. The trusses and sheet metal roof now peak at 15.5 feet. An extra sheet metal panel was fitted at one side to compensate for the additional height. The controls side has been left open to access the runways without stooping down. Katool recommends use of a crane or forklift for unpacking the lift and assembling it. I highly recommend that you do so. We could not get a forklift into our site, nor would a gantry crane fit. As a result, the heavy runways were carefully maneuvered with a 1-ton rated engine hoist, updated with an 8-ton air-over hydraulic ram. The lengthy runways are the heaviest components. We managed to unload and position the runways without a mishap. A stout furniture dolly helped move each unloaded runway from the side of the trailer into the carport. Again, a forklift or crane would make this task easier. Lifting and supporting a runway requires safety equipment. 2,500-pound capacity commercial pipe stands helped here. On an open shop floor installation, using a suitable forklift or rolling gantry crane is advisable, safe, and practical. The best assembly method is by the Katool manual steps. I got the latest update instructions, and assembly was straightforward. Some YouTube installers have noted that they needed to remove the pulleys to run cables through the columns and crossbeams. This was not necessary with my lift. Perhaps Katool has improved its pre-shipment packaging. Cable installation was possible with the pulleys in place. I reread the instruction sheets several times to better understand the logic behind the assembly sequences. Before feeding the cables through the crossbeams and up the columns, I preset the crossbeams at the height indicated in the manual. The 4 cables are each a distinctly different length. Cables were laid out and partially installed at the factory on my KT-4H110 lift. Important to note, the power side runway's power cylinder needs to be carefully extended for the needed cable slack when routing the cables. This may seem backward, but the cables loosen or slacken with the rod extended. This lowers the lift. When hydraulic power applies to raise the lift, pressure is applied to the top of the cylinder's piston, which pushes the piston and rod into the cylinder. As the rod shortens, the 4 cables pull the lift's crossbeams and runways upward. To extend the piston and rod during assembly, compressed air is injected into the cylinder's small plastic exhaust tube. Using short bursts of clean compressed air, the cylinder's piston and rod move slowly at a controlled rate. This prevents damage to the cylinder, rod, piston seals, and cables. The different length cables were sorted out before the lift shipped. Cables were loosely fitted around the correct pulleys and ready for assembly. This was a major time saver. With the required cable slack, the cable ends readily fed through the crossbeams. Slack helped loop and feed the threaded cable ends through the lock system and up the columns. The latest version of the instruction manual is more detailed. Earlier installers at YouTube were on their own with the old instructions. Included in the latest manual or the online download instructions is a helpful color diagram of the cable routing, which sorts out the cable paths and illustrates the way cables operate. The illustrations clarify how the lift works. A key step is to make certain that the cables fit through the crossbeams and lock mechanisms correctly. Avoid overlapping or crossing up the cables within the crossbeams. Cables must run straight between their pulleys. Avoid tangling or crossing cables. When attaching the runways after routing the cables through the crossbeams, make sure that the runway attachment bolts do not trap or pinch the cables within the crossbeams. Katool instructions describe this concern. The cable should center in the crossbeam when the slack is removed. I tension the cable by hand while fitting the bolts through the crossbeams. Do not apply power to the lift until you are certain that each cable is routed correctly. When removing slack at the cable adjusters, the amount of thread showing above the column should be reasonably close for each cable. If the floor is flat, runways are level, and columns stand vertically plumb, the cable should have roughly the same adjustment or slack at each column. If the length is way off, trace the cable routing. Cables may be switched or misrouted. The floor, crossbeams, and runways must be level for the cable adjustments. Fine adjust the cables to make the runways lift and set squarely. The slotted ladders also need height adjustment. The locks click into each slot as the runways rise. At the desired height, the platform is lowered until it rests on the closest ladder slots. It is important to adjust the ladder heights to have the runways and crossbeams level when the platform rests on the ladder slots. After brief use with vehicle loads, check all adjustments. Cable seating and component break-in may require minor adjustments. There is a reason for the sequenced assembly steps in the latest manual. These steps are the easiest way to assemble the lift. Sometimes questions arise with your particular equipment, maybe the assembly steps or parts in your shipment. In my package, all pieces and hardware were included and matched up. If you do encounter problems during assembly, contact Katool Tech Support. They will walk you through the process or sort out any parts issues. One small change that I confirmed is the power cylinder's exhaust tube routing. According to earlier instructions and YouTube reviews, the small diameter black air hose attached to the return fitting on the hydraulic pump. This has appeared in YouTube coverage of the KT-4H110 lift. The latest instructions clearly state not to attach this exhaust air line to the pump. I'm guessing that returning air to the pump may have created aeration in the hydraulic oil system. In the manual's illustration, the hose now vents to the atmosphere. Since piston and rod movement creates a low-pressure vacuum at this exhaust tube, I am concerned about debris or dust getting drawn into the lower cylinder. I contacted Katool Tech Support by email, and they confirmed that the plastic tube now stops at the edge of the power runway and vents to atmosphere. Not content with that arrangement, I installed an inexpensive, easy-to-service inline paint gun filter on the end of the exhaust line as shown here. This is a choice I made, not a directive from Katool. The plastic filter prevents debris from being sucked into the cylinder when the piston and rod move outward. This filter will not block airflow in either direction, but will prevent debris from entering the cylinder and damaging the cylinder's wall or seals. At the start of the lift installation, I carefully followed layout measurements described and illustrated in the assembly instructions. Plumbing each column with a level and measuring lengthwise and in cross between the four corners will assure a square fit. Once columns were square and on specifications, I drilled the pad anchor holes with a rotary hammer. I started with a 3/4 inch carbide concrete hammer bit for pilot holes and finished with a 19mm bit to match the diameter of the furnished anchors. The two drill sizes made the holes straight and true. The columns got leveled with special hot-dip galvanized heavy-duty metal horseshoe shims. These shims are low-carbon steel and engineered for heavy pieces of equipment. The Katool wants no more than 5mm of shimming at the column base. This works fine on a flat level floor. In my installation on a previously poured carport slab, that minor level of shimming was not possible. This is why I opted for heavy-duty, wider coverage steel horseshoe shims that straddle the anchors and spread the load out to better support weight. Note that my shim stack heights are not recommended by Katool, and I am not suggesting that others take this approach. I will keep a close eye on column plumb and the wedge anchor's nut torque. Anchor nut torque should be checked regularly on any 2- or 4-post lift installation. An air gun can damage the wedge anchor or pull the anchor through the concrete. Anchors that continue to loosen need replacement. If quality concrete is not holding with wedge anchors, There are alternatives like high-tensile rods and special concrete setting compounds specifically made for securing threaded rods in concrete. Each column plumbed and well supported at its base, I torqued the wedge anchor nuts uniformly to specification and not over-tightened. The lift is square, and the columns are straight and stable. I have rechecked the nuts since testing the lift. Again, tight is right, but not over-tightened. Do not exceed the torque specified for the wedge anchors and concrete PSI. After installing the hydraulic system and adding a NEMA 650P welding plug at the new 220-volt motor, the last steps were fine adjustments of the release lever and 4 locking mechanisms. I rechecked lift ladder heights and the cable settings to make sure the runways and crossbeams were level. Level runways will keep a vehicle from rolling and assure accurate wheel alignment. Wheel chocks are still recommended for vehicles on a 4-post lift. The lift ready for testing, I filled the oil tank with premium ISO 46 hydraulic oil. With a 220-volt motor plugged into my welding extension cord, I pushed the start button, and the lift worked. It's exciting to furlough my creeper and let the Katool KT-4H110 lift and RJ70 rolling jacks take over. The lift and rolling jacks are a game changer for chassis, brakes, steering, suspension, and framework. Powertrain and axle service are readily accessible with a wide space between the runways. Transmission, transfer case, and gear work will be much easier to demonstrate in film now. With double parking space at the lifts, the 3-car garage plus carport service bay serve as an affordable, fully functional automotive shop for maintaining and repairing vehicles. By performing all service work myself, the Katool lift with rolling jacks will quickly pay for itself.